Assalamualaikum everyone. We are from group 1 and today we are going to present to all of you about power. So, this is our lovely group members. Okay, now let's begin with the introduction from Liyana.
Powers are a method of simplifying expression. Powers are a way to write that we have multiplied a number by itself a given number of times. For example, 4 squared is 4 to the power of 2 equivalent to 4 times 4, and 5 cubes is 5 to the power of 3 is equivalent to 5 times 5 times 5, 3 times. So generally, for any positive whole number, n is x to the power of n equivalent to x times x times x according to the n number. Okay, so we look here, we have 4 to the power of 4. So 5 is called base and 4 is the index of the base or its power. And the most common way to describe this expression is 5 to the power of 4. Okay, next, negative power. When negative number be powers, it gives fraction called reciprocal. Generally, x to the power of negative n become 1 over x to the power of n as long as x not equal to 0. Okay, for example, 2 to the power of negative 3 become 1 over 2 to the power of 3 or equal to 1 over 8. Second, 3 to the power of negative 4 become 1 over 3 to the power of 4 or equivalent to 1 over 8. Okay, we have two special cases in powers. Okay, number 1, if any non-zero number raised to the power of 1, it becomes itself. For example, 3 to the power of 1 equivalent to 3 and 15 to the power of 1 equal to 15. So generally, x to the power of 1 equal to x or itself. Number 2, if a number is raised to the power of 0, the answer is 1. For example, 4 to the power of 0 equal to 1. So generally, x to the power of 0 equivalent to 1. Okay, we have 5 rules of power. Number 1, when we want to multiply powers of the same base, we just add the indices. Okay, we have formula a to the power of n times a to the power of n becomes a to the power of m plus n. So for example, a to the power of 7 times a to the power of 2 becomes a to the power of 7 plus 2 equivalent to a to the power of 9. For second, when we want to divide power of the same base, we just subtract the indices. Okay, for the formula is a to the power of n over a to the power of m. It becomes a to the power of m minus n. Okay, so for example, a to the power of 9 over a to the power of 6 equivalent to a to the power of 9 minus 6 and becomes a to the power of 3. Okay, for rules number 3, when we to raise a power to a power, we just multiply the indices. Okay, for example, a to the power of n times m is become a to the power of nm. For example, a to the power of 2 times 3, it become a to the power of 6. Okay, for rule number 4, a power of a product is the product of the powers. Okay, and we have ab times to the power of n, we just expand it, become a to the power of n, b to the power of n. Okay, for example, 3 times 4 to the power of 2, we expand it, become 3 to the power of 2 times 4 to the power of 2. Okay, for rules number 5, a power of a quotient is the quotient of the powers. When we have a over b to the power of n, we expand it, become a to the power of n over b to the power of n. For example, 5 over 2 in bracket to the power of 2, we expand it, become 5 to the power of 2 over 2 to the power of 2. So the last topic is root. In general, the opposite of raising a number of x to the power of n is to find the n root, which is denoted as root of n. We also can use fractional powers to write root. For example, square root of x equivalent to x to the power of 1 over 2, and cube root of x equivalent to x to the power of 1 over 3. So generally, root of n of x equivalent to x to the power of 1 over n. Okay, for example, square root of 16 equivalent to 16 to the power of 1 over 2, or equivalent to 4. Cube root of 27 equivalent to 27 to the power of 1 over 3, equivalent to 3. And root of 32 root of 5 equivalent to 32 to the power of 1 over 5, equivalent to 5.
Next, we move on how we can apply power concept in chemistry. As we know, chemists often deal with quantities that are extremely small or incredibly large. So the way that chemists handle all those quantities and numbers is by using power concept. Okay, let me give you an example. The first one is Rybert constant. Rybert constant is physical constant that related to electromagnetic spectra of an atom. If we take a look at the numbers, it has about 17 zeros in total. So by applying power concept, we can simplify the numbers to 2.18 times 10 to the power of negative 18. The second example is Avogadro constant. Avogadro constant is the number of atoms or molecules in 1 mole of a substance. If we count the numbers, it has about 24 numbers in total. Very big numbers. So we can just simplify the numbers by applying power concept, and that's how it becomes 6.02 times 10 to the power of 23. So in conclusion, chemists usually applying power concept to the numbers that are very big or very small to make it simple and make them easier to do calculation.
Okay, so let's proceed to question number 1. So the question asks to calculate the number of atoms in 0.551 gram of potassium. So first of all, we need to calculate the number of mole. So we know the formula is mass over molar mass, right? So we divide 0.551 gram over with its molar mass, which is 39.1 G per mole. So we got the number of mole of potassium is 0.0141 mole. So after that, we know that 1 mole equal to 6.023 times 10 power of 23, which is it is the Avogadro number. So to get the number of atom, we times the Avogadro number with the number of mole. So 0.0141 times with 6.023 times 10 power of 23, we got the answer 8.4882 times 10 power of 21 atom. Application of the power in this question is the Avogadro number itself. We look at the 10 power of 23. So that is the power. So the next question, how many atoms of carbon are in 0.750 mole of monosodium glutamate? The first step is we need to compare 1 mole of monosodium glutamate with 5 mole of carbon based on its molecular formula, which is NaC5H8NO4. After that, if we use 0.75 mole, so what mole of carbon we need to use? So if we look at the solution in the box, so we can get X equal to 3.75 mole. So the next step is we we need to multiply the number of mole of carbon with the Avogadro number. So the final answer will be 2.2505 times 10 to the power of 24.
So now let's proceed to question number 3. This question is in topic ionization energy. The question is, calculate the energy in joules of a photon with a wavelength of 5 times 10 to the power of 4 nanometer infrared region. The H and C value was given. So we know that to calculate the energy, we use the formula delta E equal to Hc over lambda. So H and C value was given. Just substitute it into the formula. And the lambda also given in the question. But remember, it's in nanometer. We must change it into meter by multiply it with 10 to the power of negative 9. Substitute the formula and we get the answer. But here, we use rules for power number 1 and 2. Rules number 1, to multiply powers of the same base at the indices. Our base is 10. So, we just add it. Negative 34 plus 8, we get negative 26. And rules number 2, to divide powers of the same base, subtract the indices. So, negative 26 minus 4 plus negative 9. So, we get negative 21. So, the answer is 3.975 times 10 to the power of negative 21 joule. That's it. Thank you.
First, we need to determine the mass of C. In the problem, first we need to determine mass of C. In the problem, it's known that percent C is 80% and the mass of compound is 9 gram. We find the mass of C with mass of C equal percent C multiplied mass of compound. So the percent of C is 80%, multiplied the mass of compound is 9. The result is 7.2 gram. Next, determine the mole of C with mass of C and the AR of C. We just divide of it. The mole of C equal mass of C divide AR of C. The mass of C is 7.2 gram divide AR is 12. The result is 0.6 mole. And the last step, we just multiply the mole of C with Avogadro number. So 0.6 multiplied 6 multiplied 10 to power 23. The result is 3.6 multiplied 10 to power 23. So that's all.
Here we are on the last question of subtopic power. If you read out loud the question, this question is about chemical equilibrium. This question uses all rules of power, which is rule number 1, 2, 3, 4, and 5. It applies on the number and the unit itself. For example, as you see on the second line of the solution above the divider, it uses the rule power 3, rule power number 3, which is a number that was powered by negative 4 was again powered by 2. It applies the powers to multiply by itself. As for the unit, which is molar, that was written as capital M, it was m to the power of 2 that was divided by m to the power of 4, which makes it subtract by itself, makes the molar equal to m to the power of negative 2.